on the surface of a sphere, a triangle always has more than 180 degrees. On the surface of a plane, a triangle always has 180 degrees. Exactly. So if the Earth is flat, then any measured triangle, every one of them will be 180 degrees. And if the Earth is round or spherical, a sufficiently large triangle so that the measurement, the precision of the measurement instruments can resolve it, there will be more than 180 degrees in any triangle. There are no assumptions in this at all, nothing. So right there is just a little description of how it's done. It's called, the amount over 180 degrees is called spherical excess. So if there's any spherical excess, then you know that the Earth is not flat. And here's a little more. This is on my website at mctoon.net/SE. All of this stuff is on there. So all my data is cited there. This shows a little bit with how the triangles work. Since the triangles are not in the same plane on the surface of a sphere, the angles are greater than 180 degrees. So there was a survey. It was published in 1900. It's a 900-page survey. It's called the Transcontinental Triangulation of the American Arc of the Parallel. I sent this to Austin more than a year ago, so he's had plenty of time to see it, to review it, to read it, to become familiar with it. I'm sure he has. They used these theodolites. These are 20-inch long theodolites, very, very precise, better than 1 arc-second of precision in this. In order to sight them, they set up temporary housing, temporary viewing stations on mountaintops, especially across the Rockies. And they use what's called a heliotrope on the ones that are being sighted. So one person's on a mountaintop with a theodolite, and then there's several people at different mountaintops with heliotropes shining these mirrors on the top toward the other place so that they can sight the different locations. So they have a shiny point to measure towards. Here's somebody using a heliotrope. You can see there's a telescope on it so that they can view the person with the theodolite who is measuring the angles. Now, you may be wondering, how did they deal with refraction? And that is an important issue. It is covered in there in the book, the survey. The thing is about horizontal measurements or azimuthal measurements is refraction does not affect it. It does affect zenith measurements a lot, but it does not affect horizontal measurements. So they go over that in the book. And the way that you do get variations due to potential atmospheric effects dealt with is you take lots of measurements, lots and lots of measurements. They take huge numbers of measurements. They get a really tight standard deviation so that they know that the measurements are very accurate. Mount Loma, Mount Diablo, and Mount Helena, which are in Utah, Nevada, and California, they have the observed angles right there, 28 degrees, 49 arc minutes, 8.348 arc seconds. The important thing there is that little number at the bottom, 57.778. That is the spherical excess. That is the amount over 180 degrees that triangle summed to. There are no assumptions in this. It is just a horizontal measurement of these three angles from these three mountaintops, nothing more. It sums to more than 180 degrees. Therefore, the Earth cannot be flat. Now, the thing is, there are hundreds and hundreds of these triangles in this particular survey, just this particular survey, and I have 5 others linked on my website at mctoon.net/SE. You can see here, 50 degrees, 50, these are arc, and it's over. So that is right there what I would ask anybody to explain. If the Earth is flat, how come all of these triangles do not sum up to 180 degrees? And if you think there's any assumptions in here, please be very specific in what you think they are.
So I think there are many scientific reasons for the Earth being round, but there are also many ways that we can observe the Earth being round just by using our eyes, using our senses. And that is why even before Christ, right, in 200 BC, Aristophanes actually measured the circumference of the Earth. He used the sun. There are many it was very like accepted even like over 2000 years ago, and there are so many things that we can actually just see and visualize and experience that will lend itself to a spherical Earth. So some of those things that we can see on a day-to-day basis currently is that for lunar eclipses, we see them at many locations of the Earth. And if you see a spherical or a circular shadow at many different angles, that means that the whatever you're looking at, the shadow of whatever you're seeing is spherical, right? There's also other things that point very clearly to a spherical Earth, such as consistency of the stars. In the northern and the southern hemisphere, Polaris is constant in the northern hemisphere, and you see the other stars rotating around Polaris from our vantage point. Similarly, we see that in the Southern Cross. And also there's some things that it would not add up. So we also see the same face of the moon wherever we are, right? And that would not be possible if we were on a flat plane. So for example, if we were on a flat plane, if the moon was spherical, then someone very far away would see a different face of the moon than someone beneath the moon. Or if the moon was a disk, then it would not look circular. It would be distorted depending on where you were on the Earth. So there are many inconsistencies with a flat Earth model that can be observed just by the naked eye. You don't have to know a lot of science. You don't have to understand all of like the mathematics behind it. These are things that are very demonstrable. And those are just to name a few. There's so many things that prove that the Earth is spherical.
What up? This is the beautiful Kai.
Hello.
And I am What's It Gets It. We put this together really fast, but the Earth is flat. Don't make this weird, bro. So we're curious as to which one of these is the real curve of the Earth. So once again, here's the fisheye of the infamous Felix Baumgartner jump. This is infamous astrophysicist, scientific communicator Neil deGrasse Tyson. Let's hear what he's got to say about it. Hopefully the audio works.
And the dude who jumped out of a perfectly good balloon, what's his name? Felix Baumgartner. He would have been about 2 millimeters above the surface of this globe. That's his edge of space jump. Now, you know, I don't, it's he wants to, I don't have a problem if he does it, but the honesty of it would greatly diminish what I think people thought he was actually doing. And not only that, they made sure to photograph him standing there with a really wide angle lens, which curves horizontal lines. So in the photo, you see this curvature of Earth's surface, and he said, wow, he's in space, look at that. No, he's not. At that height, you don't see the curvature of the Earth if you are 2 millimeters above this beach ball. You just don't. That stuff is flat.
Interesting. Here's a quote. We put it up here for you. Then we wrapped the flat map around the ball. My part was integrating the surface, clouds, and oceans to match people's expectation of how Earth looks from space. The ball became the famous blue marble. So it's not a real picture. It was the default picture on the iPhone. But again, they're showing all these fake pictures of curvature, but it's probably because they're telling the truth. Here's all the different pictures of the Earth, and I guess the Earth changes from year to year. They can't figure out it has bipolar.
The size of the continents are changing.
The colors change.
Yeah.
You know, well, we're crazy. You got to believe that these are real, or you are a conspiracy theorist. I like this.
Okay, so again, they say that the Earth is a ball. One main proof that they have is things disappearing behind the curvature of the Earth. So they use like sunsets or ships disappearing over the horizon as evidence that the Earth is a ball. But you can see here that things in the distance converge with the horizon. You can see with the street lamps, the farther the street lamps are from you, they begin to merge with the horizon. It almost looks like the street lamps are setting. You can see the hallway as well. The further distance, it merges with the horizon. We have a couple pictures, or a couple videos. The first video we have is a boat. So again, I'll say, oh, the ship is disappearing behind the curvature of the earth. When you zoom into the boat, you can see it again. So it's not actually disappearing behind anything, because if it was being physically obstructed, then you couldn't zoom in with the camera. Just like you can't use a camera to see through a brick wall or a mountain, you can't have a camera see through a hump of Earth's curvature. So the real reason that boats are disappearing is not behind the curve of the earth, but simply it's just leaving your field of vision. We also have another video here. This explains how sunsets are working on a flat earth. As the laser gets further away, it's not going behind anything, it's on a flat surface. It's just leaving your field of vision.
The second law of thermodynamics dictates pressure will fill the available space, spontaneously seeking equilibrium. This is, of course, a natural law, not a theory, not debatable. The globe Earth belief system loves to handwave dismiss the second law as if it's flexible or they can make it up or whatever. But here, I'll let you commentate this. But here's a little demonstration of the very simplistic idea of gas filling the available space.
So you can see here gas inside a vacuum chamber fills the available space. And then once
if you're able to just, it's really, I think that they maybe won't be able to hear you while the music's going simultaneously.
All right, my bad. I turned it down. Here you go.
You got it. Go ahead.
Okay, so the second law of thermodynamics describes entropy, high pressure going to low pressure. You can see here that also that gas fills the available space. Inside a vacuum chamber, the gas is still filling the available space. And then once the lid of the vacuum chamber is removed, you'll see that the high pressure in the vacuum chamber fills the available space. Which is the surrounding air. The reason this is relevant is because we know we have gas pressure here on Earth, and they tell us that outer space is a vacuum, and they also say that the atmosphere is uncontained.
So here's the government telling you numerous times that the only way they can do anything with practical use cases when people's lives are at stake is to assume the Earth is flat. And of course, here we have the air trajectory model. The only way you can even design an aircraft is to assume the Earth's a flat, non-rotating surface, as do pilots when they fly them, where people would literally die. They don't assume that the Earth is curving down beneath them or spinning because literally they couldn't fly the plane. Here are numerous states, science. Several U.S. states, led by Florida, are flatter than a pancake. There's like a list of 11 or 12 there. 10 flattest places on the Earth. You got all kinds of different places that are incredibly flat for immense amounts of distances. But the Earth is a globe. Obviously, it's just flat everywhere for hundreds of miles everywhere. And they admit it. And this is coming from physical empirical measurement, unlike MCToon's little look at something in the distance and presuppose spherical excess. But we'll get into that later, I'm sure. So anyway, the Earth is such a ball that it's flat everywhere.
And so this is based on, so they told us that the radius is 3,959 miles, which means that the drop rate will be 8 inches per mile squared, I believe up to 1,000 miles. Mm-hmm. So you can see here in the chart, obviously the first mile, there's an 8-inch drop, but as you get further on, for example, 100 miles across, there should be a 6,666 foot drop. So if this curvature rate is real, if the globe is actually real, you should be able to easily detect this, and they can't.
So, and here you guys have probably hopefully seen it, the infamous black swan observation. So for those that don't know, the reason it's called a black swan is because if you say all swans are white, and then you find a black swan, that nullifies or falsifies the notion that they're all whites. You just have to find one black swan. Then your statement that all swans are white isn't true, right? This is the globe Earth's black swan. That means when people run away, they just parrot the word refraction, which we can definitely get into the depths of it, right? It doesn't change anything. If this happens one time, the radius is wrong.
All right. Hey, I'm wondering, why did you not use, why didn't you look up, Austin, what the actual source was for the 1.22 times feet in height? Why didn't you look that? A couple months ago, I asked you where Quantum Eraser got that, and you didn't answer me. That's don't worry about it. Here's the deal. Let me share this because I want people to see. I know where he got it from. he got it from Andrew Young.
The subject matter expert, Andrew Thomas Young, our favorite guy.
That's who he got it from. This is the page that he lifted it from, right? Is this being shared? Okay. So you see right here, this is the no refraction part of the page, right? And right here, 1.23 or 1.225, he rounded up, times the square root of the eye height in feet. That's where Quantum Eraser got it from, okay? That is, again, from Andrew Thomas Young, Quantum Eraser Loves the Sky.
Andrew Thomas Young, San Diego State University, Astronomy Department. So, Andrew Thomas Young, San Diego State University, Astronomy Department, the subject matter expert.
The subject matter expert, excellent. So the problem is that Quantum Eraser stopped reading at this point, and he does not read on to where Andrew Thomas Young talks about refraction in measuring the distance to the horizon. And that's the crucial point of your black swan image there, is that there's no refraction. That's the most important part of that. There's no refraction involved. Yet Andrew Thomas Young, the source of that formula from Quantum Eraser, talks about refraction in detail. Look at the rest of this page. That page is significantly longer than just this first part that Quantum Eraser likes to look at. Now, okay. Austin, I know that you love demanding that refraction happen.
Refraction, which we immediately and adamantly claim is always present because there's temperature fluctuation and atmospheric conditions that are consistently affecting what you perceive.
I completely agree. So be sure, Austin, in your analysis to include refraction, or I will just play this.
Refraction always happens
over and over again.
It's important.
It's just theoretical to explain this rate we need if the Earth's in fact a ball. So you actually have to reify the R value that's being contended and falsified, and then you have to extend it and then say, look, this formula proves it.
But I don't use that particular measurement or observation to measure the radius of the Earth. That's done external to that particular measurement. It's already known what the radius is. But no, it doesn't matter. You cannot look at that photograph without including refraction in the analysis.
And never the radius dissecting of the observations, you even account for refraction that we know for a fact to be present.
Absolutely.
Bro, does the radius change? Like when you put 7/6R, can you change the radius?
No, but refraction changes what you see.
When you just throw refraction out entirely, invoking the furthest point away in the image and saying that you don't have to account for refraction and making the baseless assertion it doesn't move it because you showed us some really not very great images where they look to be generally the same is laughable, bro.
That's laughable, bro.
You're making an additional claim. You're actually claiming it's a physical, actual location based on.
I didn't claim. Well, this is your picture, not mine.
So do boats go over the curvature of the Earth, MCToon?
Absolutely, they do get obstructed.
So you do claim it's physical. Yeah. Thank you, man. Thank you for
Yeah.
just contradicting yourself instantaneously. So if the Earth is a radius value of 3,959 miles, there's a physical obstruction. Flat Earth knows that the horizon is just apparent, constantly fluctuates. We showed that. I don't know if you were paying attention to the presentation. We actually showed a time lapse where the horizon constantly moves.
Absolutely, yeah. That's why you need to include refraction analysis.
But if your refraction
you made my point.
If it requires the reification of the R value in contention, it is inadmissible, my friend.
No. The radius of the Earth was measured external to that particular observation. That's all I'm asking.
Hold on. I think what we're missing here is that radius is constant and refraction is a variable. So that might help you in answering Melvin.
No. What will help me is if you know what the subject matter expert says, which is that you have to invoke terrestrial refraction and fluctuate the hypothetical R value to 7/6R just to get an idea of it. Then you must, in fact, invoke and reify the idea of light rays, which are just an unrealistic concept. This is all coming from the subject matter expert. And that you didn't have to ignore the fact there is no horizontal boundary. So you must assume the Earth's a sphere, assume the R value, fluctuate it hypothetically, which is a category error because you're talking about light over top of the Earth, not the Earth's terrain itself changing. And then you have to invoke light rays, which aren't real. That's what the subject matter expert says. So we're actually hitting the R value.
Here's the deal. According to your own demands, you've still not included the refraction analysis. I'm just waiting for that. Go ahead. It should be, yeah. Definitely.
Okay, so then you can never actually see the literal curvature of the Earth then, right?
Everything we see goes through a medium. So everything we see is modified by that medium. So you just need to control for those conflating variables.
So we can never see the actual curvature of the Earth then, right?
You can never see anything that is just unmodified by the medium through which the light travels.
So we can never see the actual curvature of the Earth then, right?
You can never see actually anything because everything is different. Are you that stupid that you don't understand that, that there's a medium? There's a medium.
Live on a ball, okay? For example, a pregnant lady's stomach, right? When she's 9 months pregnant, her belly physically obstructs her ability to see her feet, right? Okay, but you're saying that on your in your reality, you can never ever see this curvature of the Earth. Now you say that both
can't see it unmodified.
You're saying that
so
both
stop straw manning me.
Are you
can never see it.
No,
because you're straw manning me. I'm not gonna sit here and let you straw man.
You're making contradictory statements.
Here's the deal. Everything you see is modified by the medium through which the light travels. You just need to take into account these modifications.
So we have to assume that it's there. We never see it's there, but we have to assume it's there and then make up math to explain why we don't see it.
Just all you need to do is control conflating variables. That's classic science stuff. If you don't like doing it, I understand, because it gives you the result that you don't like. No, I'm sorry, you don't understand how controlling conflating variables works.
What is it with his info? Aren't you like, what the heck?
Wow,
he's like literally explaining you like the science, like how to actually, you're saying that like controlled studies, you actually have to like control whatever variable. What? No, you have to measure with it. You have to see the effect of it, and you have to like take that into account. That's all he's saying. And you are 100% strawmanning him.
I don't think you necessarily understand the issue. As you said earlier, that with our senses, right, we can know that the Earth is a sphere. Here's the problem: there's a claim that the Earth is a certain size and there's a certain radius value.
Of course.
If it's so obvious that this curvature exists, then we have to be able to measure it and detect it. Okay.
Yes.
But here's what MCToon is saying. MCToon is saying that you can never actually observe the curvature of the Earth because of refraction.
That is false, because we can measure refraction and we can control for
so if we never actually see the curvature of the Earth, how do we establish that it's there?
So we can see the curvature, but it is as you were saying, a modified view. We can see it changing. You are interrupting a woman.
Yeah, somebody just interrupted a woman.
You're seeing the change of the curvature to an extent, and that's because of the refraction. But just because you see changes in it and illusions doesn't mean that the curvature itself is not there, right? So like if it's nighttime, and you know that there's a tree, where somewhere, and you're like, oh, I know that there's a tree there, and if you like shine a light there, you're like, okay, so how do you know? Because you didn't actually see it without a light. You're controlling for the darkness, which is a variable, by using a light. It's the same type of thing, that there's a variable that's impeding your measurements. So you measure that variable, and then you're able to take it away and to have an actual accurate measurement.
The definition of the horizon is the apparent location where the sky meets the ground.
Correct.
The apparent location. But in the heliocentric model, with the globe, the horizon is actually a physical location, but that's
so you can't necessarily say that like, oh, there is one definite. Of course, all horizons are based on your perception. That's the way horizons work.
But see, Carissa, that's our argument.
But that doesn't mean that it doesn't exist.
The globe argument is that boats and ships and the sun is disappearing behind a physical location.
And it's interesting.
But now you're saying that you're saying so there's the ball is a specific size and it doesn't change, right?
Correct.
It doesn't change. Okay, it's 25,000 miles in circumference. It doesn't change. But what you're saying is that we're seeing the horizon change in distance. And that can't work if the horizon is a physical location.
It's not. Horizon is perception, and the earth curve is physical. So when you see a horizon, you are viewing. Hold on, can you stop interrupting a woman? When you see a horizon,
that was pretty funny.
When you see a horizon, that is your perception of the static Earth's curve. So there's going to be some variables within that curve, right? That's affecting it and affecting your perception. We don't have like telescopic vision, and similarly, there are some elements, there's gases in the atmosphere. I'm sorry, that's just the way it is. But we can measure those things. We can measure effects that it has on our vision of the our vision, and then we can measure it and we can account for it, right? That's like literally how every single scientific study works, even if it's not observational.
Yeah, but let's just recap, right? Because what you've said like 3 times now is, well, that doesn't mean it's not there. Well, I've never seen Superman, Carissa. That doesn't mean he doesn't exist. Yeah, she said just because you never actually see it, that doesn't mean it's not actually there. Well,
It means
I've
you
never
can
seen
control.
leprechauns.
You can
Dude,
control for that variable. That's
you
what she means.
Yeah.
No, you can't control the atmosphere. So
That's
she
not
said-
what she's saying. Don't straw man.
Okay, so you want to move on to that? You concede that optically.
I don't concede. No. I concede that you did not include refraction in your analysis, which you demand must be done.
Yeah, we actually, in our presentation, we showed you a GIF. It says atmospheric refraction right below the
But
GIF.
you did not include atmospheric refraction analysis in that black swan image. As you demand, must be happening.
Okay, just to clarify for the audience, right? Because there's some new listeners here.
I'm claiming that you haven't even actually accounted for all the variables, and you're touting your trigonometry that literally hand waves dismiss one of the most important variables when it comes to perception, which is refraction.
There you go.
All right, so just
Be a hypocrite.
just to clarify for the
Hand
audience,
wave away refraction. Go ahead. Hand wave refraction. Be a hypocrite.
you're triggered, bro. This is weird. You're making it weird. You need one of my shit.
Hand wave. Hand wave away refraction. Go ahead.
Can you give me your visualization of how the map of the Earth would look?
So I understand why people would want a model, but we don't actually have the positive claim.
Okay.
So the positive, because you again, I'm going to bring up what you brought up is our senses. It's common sense that the Earth is a sphere. But we actually don't observe curvature. We don't observe axial rotation.
No, that's not what I'm asking. I'm asking.
No,
for
I
the
understand.
map.
I'm saying, but we don't have these positive claims. We just falsify the positive claims of the globe.
Okay,
We
so
can never know. We can
you
never
think it
know.
might be a square, or do you think it's actually
No,
flat?
no, we know
Because your
no.
shirt has the positive claim of the Earth is flat, so you literally are making a positive claim. I'm just asking you to substantiate it.
We don't have the positive claim.
Your
The
Earth,
claim
your
of Earth is
literal
flat.
shirt is a positive claim.
Okay, so the globe has a positive claim because in our day-to-day reality, we observe the horizon, the horizontal horizon. We observe flat, stationary. You don't observe spinning 1,000 miles per hour. You don't observe gas pressure without a container.
So when you're in
Earlier,
an airplane,
when you
do you
cracked open-
observe?
Earlier, when you cracked open your little soda can, you just demonstrated the second law of thermodynamics, okay? And the globe model argues against that. So you do have the positive claim. We don't have a model. We can never know what the actual Earth looks like. All we know is that 1, it measures flat. 2, it's stationary. And 3, there must be some kind of container because we have gas pressure. The definition of gas pressure has container in the definition. So we know that it's not an open system. And the vacuum of space cannot exist.
Do you
We don't have a
understand
model.
that
So
a vacuum?
long story short, we don't have a model.
Do you believe in gravity?
Believe in gravity? Well,
Yes.
let's actually define gravity. Which type of gravity are you speaking?
A vector that has
There's
for this
multiple types.
discussion is a force. It has a direction, and it has a magnitude. It's a vector. Do you believe in that?
For science, first of all, just for science, there should be no belief, right? That's kind of the antithesis.
Okay.
Antithesis of science. But what you're
Does
talking about
gravity
actually-
exist? Let me rephrase this for you. Does gravity exist in your opinion?
Okay, my opinion is irrelevant, but let's go ahead. So you're talking right now about Newtonian gravity, which is mass attracting mass, which said that gravity is a force, okay? And he demonstrated that kind of like the way to think of Newtonian is like the apple falling from the tree, and it's falling to the ground because the mass of the earth is pulling the weak mass of the apple. Well, that was actually superseded by Einstein. So now gravity, when you're talking about gravity, you're talking about the bending and warping of space-time. I can pull up some
But for
academic
this,
sources
for
for you.
this, I understand that, but for this discussion, it can be viewed as a force. Just for
No.
just this contained discussion of what I'm asking. Do you think it has a magnitude?
Why
And do you
would-
think it has direction? That's all I'm asking.
So we're here to debate the heliocentric model. If you're not fully educated on the heliocentric model,
I'm not saying it's a force.
Talk
I'm
down
saying
here
it's
like that?
acting as
Wow.
though a force. I'm saying it's acting as a force. Correct.
Gravity is not a force.
So we have an agreed upon average of 9.8 meters per second squared of an observed phenomena called downward acceleration on the Earth. Now, this is just an agreed upon average for intents and purposes.
It's not agreed upon. It's measured.
Is it always exactly 9.8 meters per second squared?
No, but it's measured.
Okay, it's an agreed
It's not
upon
agreed
average.
upon. It's not an agreed upon average. It's a measured average.
Okay.
You don't know what a measurement is? You don't know how to measure the downward acceleration? It's measured, not agreed upon. It's empirical.
Can you answer my
It was
very
hurtful.
simple question? It's
Air is
just
a
like
combination of
elementary,
different
maybe
gases
middle
and-
school. No,
I'm sorry
particles.
that
I'm
you-
talking about particles. I'm talking about
You're-
the
You're
elements.
out of your league.
The table of
Carissa.
elements. The table of elements. Just tell me, okay, if I'm out of my league, then please just answer my simple
Wow,
question.
what a dick.
Okay, calm down.
It's okay. It's okay.
It's okay. The Earth's not a globe, but don't make it weird for a sec. Okay. So look, we have an agreed upon average of 9.8 meters.
A measured average.
Okay, MCToon, calm down. So that's just an effect. Okay, it's just an effect. Downward acceleration. Gravity claims to be the causal agent of that. So when you invoke downward acceleration, cool story, bro. No flat earther says that some things don't fall to the ground. But actually, what you guys run around acting like is as if everything falls to the ground, even though things go antithetical to the singular vector down to the relative mass of the center of the Earth, right?
Of course they do, because they're lighter than the particles.
Welcome to
surrounding
Flat Earth,
them.
Carissa.
No, it's welcome to 8th grade science class that we need to
Okay.
teach you again that you didn't
Okay.
pay attention to the first time.
So whenever the only thing you can empirically verify is the density relationship affects directionality, and that's what we say. I can actually get much more specific, and MCToon, I can guarantee you, I'm trying to give you a heads up here. You're not ready, bro. Okay, so she already handled Carissa and you very sufficiently. Would you like to acknowledge that you don't have an empirical evidence of the bending and warping of space-time, which is the current rhetoric of the heliocentric model?
Not at all. Eddington, 1915.
1915 proved space and time bend and warp. Please enlighten us.
Eddington, 1915 was the first empirical confirmation of space-time bending.
When did they isolate space-time? How do you do that?
It was an I'm sorry, I'm not playing your you don't understand science game. Okay, it's a peer-reviewed, published experiment that Eddington did in 1915.
What did he do?
Confirming the bending of space-time.
How do you do that?
What do you do?
That was the eclipse of 1915.
Whoa. So he looked at the sky and proved that space and time.
Most intellectuals view the Earth as being a sphere, and
appeal to majority.
generally
Wow.
No, I'm not making that as an argument. I'm saying it's been empirically proven, and 99.9995 of any academic sources are going to tell you that.
I've not seen any academic sources saying otherwise at all.
Because they're censored and people will be fired. But anyway, her turn.
So hold on. I want to get back to my point. So I'm going to explain to you and to the audience what air is. So air is a collection of elements: nitrogen, oxygen, many others. And if you look at the periodic table, you see helium, and that is one of the lightest of the elements. Therefore, there is buoyancy and there's density. When something is lighter than other things, it will rise. But when it gets to a point in time where it is so high and there's not many other particles around it, then it will not rise any longer. Because it is heavier than the void, correct? Therefore, it stops rising because of gravity. Therefore, that is why all the particles on all the gases do not go all the way into space. It is really not that hard to understand. It just is how density and buoyancy and gravity interacts. And this is literally middle school stuff. So I don't understand why you have a smugness. It's like, oh my God, I can't even tell you what air is because I'm just so buff you. When you literally can't even answer a simple question. It's so sad.